depth and breadth into it. And that's it. Thank you.
All right. Who should go next?
Maybe Jay?
All right.
How's everyone doing? I'm Jay Rusch. I have been working on a project called Quick Blocks and/or True Blocks for about 4.5, 5 years. I was very heavily involved in the early DAO, and I fell in love with the ideas back then that this data that everyone is creating on the blockchain has to be accessible to every person that's on the chain. And if it's only accessible through big third-party database software, we're not going to end up with what we think we're going to end up with. So I'm very interested in helping people get data straight from the chain. So I run my own archive node. In fact, I run 2 archive nodes, and I've written a ton of software that lets me extract data directly from these archive nodes. And I've always used Gitcoin as one of my test cases to make sure that my software is working well. So I think it's a real opportunity for me to provide some good data. If you've ever tried to get data from the chain, you know it's really hard. So maybe the data won't be as good as I hope it would be, but the goal would be that we have excellent data to work with.
Okay.
So I like the name Disruption Joe, so I'm going to ask Joe to speak next.
Yeah. Give me just a second. Naveen, I think you just joined, right? So hello, welcome. We started with an introduction round. Please introduce yourself and take the time perhaps after the call to write a brief introduction to the Discord channel. Are you already in the Discord channel, TE Gitcoin?
Yeah.
Perfect.
I am.
All right. Good. All right. Then Joe, go ahead.
Okay, so I'm with the Gitcoin team, and I'm the main coordinator between the token engineering group and Common Stack and everybody who's going to be part of the research group. So feel free to reach out to me for whatever. I'm Joe at gitcoin.co, and I work at the intersection. I'm primarily revenue operations, kind of taking all our events businesses and grants and our kernel program and making sure that everything runs smoothly. And then I also have a focus on marketing as well. So I'm kind of here to also make sure that we're looking at the story that's created. Like the content isn't just the article we come up with at the end with the good information. It's everything that happens along the way. And this is such an interesting group of people that I'm sure there's going to be like so much valuable conversation that happens that it's just a shame the whole world can't all see it.
Yeah, by the way, we are recording, so there is at least a chance. And I hope in this group, we are not only having great conversations, but also creating great stories and narratives for Gitcoin Grants.
Yeah.
And Quadratic Funding. All right.
Absolutely.
We should go next, Joe.
Let's go with Naveen that just came in.
Hey, everybody. Naveen, currently in the Netherlands, independent researcher. I'm working with a couple of projects, MetaGov for one, in researching DAOs and online communities and governance in online communities. That's one research area, but my day job is as an independent researcher in the blockchain space at Standard Meta. And I've been following Angela's work for a long time. So I was in the WhatsApp and Telegram groups.
Oh, brilliant. And what's your background, Naveen?
Oh, master's in computer science, all computer science. I did a lot of work in consulting right out of school. Now Standard Meta is its own entity, so I'm running that.
Cool. Then you can choose who should go next.
Thank you. Yeah. Did Danilo go already, or did Jan go already?
Danilo already introduced himself. Jan.
Yeah.
Yes, so my name is Jan. Originally I'm from Slovenia, but now I live in the Netherlands, in Amsterdam. Otherwise, my background is in economics and data science. And yeah, now I work as a data scientist in fintech, more specifically in a neo broker. Yeah, and yeah, like I've been like dabbing in token engineering and just following the whole community for quite a while. So I'm super interested in just diving deep into one specific use case. So next, maybe Matus.
Yeah, I've already done it.
You already did. Okay, sorry. Then Andrew.
Hi, I'm Andrew Penland. I work at Western Carolina University. I'm a professor of mathematics. I'm not as tech savvy as most of you, but I'm very, very interested in algorithms and interesting problems. So I'm excited to see what I can contribute.
Looking forward. And I think then there's Juan left.
Hello, everyone. How are you?
Hello.
I'm Juan, and I'm an electronic engineer from Argentina. I don't have too much experience in this, but I would like to get involved in some blockchain projects and in Gitcoin also. So, and also to gain some experience in Python. So I hope this goes well.
Let's see. I think you all have your very special background and the lens you will look at this problem, and we've selected you for a purpose. All right, let's go now. Back to our slides in a moment. Okay. Hello, yeah, we already did this. And now let's have some more context, Gitcoin and Gitcoin grants. Joe, do you want to take over at this point?
Yeah, the most interesting thing about Gitcoin grants is over the just over a year and a half that 8 rounds have run, it's grown really fast to be kind of our product market fit thing, where although we were attracting developers, there was always a thought between these different, you can see on the right, there's the bounties, grants, kudos, and now we have the kernel program too. The idea lies somewhere in like work for the open internet, or maybe a world that you show your value instead of being told your value. You know, the way jobs work now is most of them are kind of, you know, we view it as they're authoritarian structures. Like you have a democracy over the top of like a country, but then you have like almost everything in your day-to-day life or companies and organizations run, you know, here's what you get because that's it. And you don't have access, versus saying this is an open system and will allow you to mine and extract value from our system, and the value will be set by the market, so you can choose to participate when it's beneficial for you. And we really are into the ideas that came out of the book Radical Markets, which its author Glenn Weil and Eric Posner have since actually kind of gone back on some of those ideas, and they said they were looking for innovative solutions, and after studying them, there's good and bad things, but the idea was, how can we actually use free markets to further social causes? And you don't hear that a lot. Like, we want to find free market solutions to solve the social justice problems of the world. And I thought at the Radical Exchange Conference, the original one in Detroit was awesome in 2018. You know, they brought in people from, you know, all walks of life. So like we have a really great distributed or set of skills here that are complementary to each other for this research group. And I felt for that conference, they really brought in minds that were very complementary to each other and necessarily complementary to each other. And one of the ideas that came out of it was the quadratic funding model that really led into Gitcoin grants. And Kevin was there, had a booth there as well, the founder of Gitcoin. And immediately it was obvious that this is a mechanism. You see groups like Zcash was one of the first where there were these huge debates, like they have a treasury, and all of a sudden you get back to this single point of failure problem again. And you're like, well, how do we disperse that treasury? Who gets to decide? Who has that power? And the quadratic funding method was a really interesting way for us to find a balance between like a one person, one vote, or $1, one vote, when you're trying to balance the two of them, where $1, one vote means that you have dollars and you're probably a better capital allocator. And we should give some reference to that. But also, if 100 people vote for it and only one votes for the other, we should lean in that direction. So finding that balance was really important. And what we've learned, some of our primary lessons have been that groups like Binance or Kraken or even the Ethereum Foundation, like they're interested in funding developers, but they want to fund the developers. They don't want to fund 90% administrative cost to get to developers, right? So the way this mechanism works, in the Gitcoin grants, is that the donations go peer-to-peer in the crowdfunding portion of it. And then we actually use a multi-sig between all the matching partners. So we never actually touched the funds. So a lot of people don't know that part of it is decentralized in that way. And so the big learning from that was, if you can provably have the mechanism work through smart contracts, that these donors are willing to put the money towards this, but they don't have the time and resources and know-how to find who's doing great things at a small level for these grants. And so we were shocked at how much they're willing to put in, especially after having seen it worked a few times. We had over $500,000 in donation last round, and we're stocking up some for each next round. So there's some ready to go for round 9 that starts on March 10th, and it'll be more than what we were matching for round 8, and round 10 will be more than what we were doing for 9. I can already tell you that, at least on the matching part. The other side of it was the mechanism itself. It attracts people to participate in the matching pool because they know the money's all going, but also the individual donors are matching more and more. And it turns out each round, usually the individual donors are getting as high as the matching pool. And it just goes to show like the strength of this crowdsourcing or crowdfunding, the mechanism by which we allocate the pool. And I'm really excited to see what we can do here in terms of studying how we get to Sybil resistance and level of collusion and corruption protection that will make this last and continue looking like the chart that we're showing right now. So, oh, you're on mute, Angela.
Yeah, thanks. Maybe we can take a closer look to that charts as well. So first, basic functionality, Gitcoin grants. You raise money from supporters, can be large, can be small, your community, your customers, your users. Everyone is allowed to place a grant and to launch a grant at any time. So there are no limitations, no restrictions. Then we have the funding rounds. These are certain periods of time where donations are collected and then be topped up with matching funds, right, Joe? And yeah, these grant rounds, as we call them, most recent one was round number 8, are happening roughly quarterly. And the matching funds are coming from partners like the list you see here on the right: Badger, Kraken, Binance, Ethereum Foundation, Synthetics, Chainlinks, Yon Finance, Balancer, Harvest. So the big names, right, in the Ethereum space. And as you can see, maybe let's take a closer look on that chart as well, because I think it's pretty amazing how the numbers are growing.
Yeah, the number of contributors has shocked us, like how much it went up, especially in round 8. But with the bull market, it gets more and more exciting. There's a thing that every grant that's out there, so the grants stay live. You put it up in round 2, it's live for the next rounds. It's live now. You could donate to one of them, but there's not a matching round going on.
Mhm.
So that's one thing a lot of people don't really get right away from the start. I also went ahead and dropped a couple links into the Discord for you to independently get like a better idea of the mechanism. So one of them is a video Kevin made that's like 2 minutes long from his website. You can look up, which is WTFisQF.com.
Mhm.
And then I also put the paper, the SSRN for the liberal radicalism mechanism, as written by Weil, Buterin, and Hitzig. And then I think I'll drop one more in here that is a good straightforward explainer.
Yeah.
If anybody hasn't read Vitalik Buterin's, he did a recap of every round.
Mhm.
Those are on
Yeah,
Vitalik.ca. So those are all in the Discord.
Yeah, and I noticed, I don't know, we have data available for this research project of round 7 and round 8, right? So the analysis is
Yeah.
basically, so we can run any kind of analysis on round 7 and 8. And I'm not sure, but I think the number of individual contributors that you can see on the blue bar and the crowdfunding amount, this is the green line, is increasing. However, the ratio is not increasing at the same extent, meaning that individual contributions are decreasing at the moment. Is this correct? Not sure. Just wanted
So
to check.
I do think people are understanding that there's a game to this. On our YouTube channel, there's the Grants Round 8 finale video where Zoe Hitzig and Vitalik and Kevin and Andreas Antonopoulos are talking about what they learned about the mechanism as it went through.
Oh, cool.
And what we found is there's this saturation point because there's this kind of game theory based thing that's going on where at first it shows you that like there's this big matching pool, there's only a few donations, so if 10 people donate like $1, that 10th person, they're seeing your $1 turned into $700 donation for this thing. But then 2 weeks later, as all the donations are rolling in for everything, people are convincing friends to come in and just donate $1, because each individual vote counts a lot more than it would in just a normal mechanism. And so we see a lot of that. There's a saturation point where all of a sudden it starts to feel like your kind of winnings, if you would, like are getting almost taken away. And it turns into a negative sum game at the saturation point. Yeah. And the other thing is we are seeing like there are more contributors, there's more big contributors, and there's more $1 contributors. And a big part of this is that collusion, civil resistance, like, as long as they're a real person, if they're putting in one vote, that's great. But we're not quite at one human, one vote, like on digital interfaces. Somebody can make a lot of setups. And yes, it is Metabase.
Yeah. Okay. Yeah, I'm just checking the chat. Brilliant. So a lot of new links in the chat. Thanks for sharing. I'll definitely check out the video with the review. I just wanted to, I think we have 2 or 3 more slides about Gitcoin grants. So this is should give you an impression, just in case you haven't been contributing or don't know Gitcoin grants yet. So there's really a broad range of different grants. So we have applications, StepNote, we have Rotkey, this is a wallet, we have Ethereum for the Farsi-speaking population, so this is education, or individuals like the software engineer asking for grants and contributions, or the Zero Knowledge podcast, or Circles UBI. So a huge, broad variety of different people, projects, and teams asking for funding. And you just go to the website and add a grant to the cart, define how much you are willing to contribute, and that's it. And as mentioned, in a matching round, you'll earn additional funds from the matching partners. Token Engineering Academy also has own grant, and I think over 3 or 4 rounds, we have collected over $9,000 US, which is brilliant and helps us to develop the Token Engineering Academy. So you always have this interface where you can see as a contributor how much this grant has collected already, how many contributors in the last round, I guess, and the last match in the last matching round to give you an impression of how this grant developed. And here are some numbers. Gitcoin Grants, I think it's pretty recent stage, over 1,300 individual grants asking for contributions. Gross marketplace value over 81,000 contributions. This was after 7 matching rounds. And we have, this is interesting, a median contribution of a little bit more than $2. So half of the contributors spend up to $2. And then since we have an average of almost $60, we also have pretty significant, much larger contributions and contributors who individually contribute much more.
If I understand this correctly, is it strategically much better to have a project listed when there is a matching round going on, or you can just list it anytime and the matching round will pick it up?
Yeah, so if your question is there a strategic advantage to posting your grant for the first time during a matching round?
Yeah, exactly. Yeah.
There's no extra boost that's given to you for posting during the matching round. So
Okay.
what we recommend to people is we do a push 2 weeks before, telling developers, especially people coming from our grants program or kernel program. So kernel is like, think of this with like 250 people doing like smart contract security work, and then there's a DeFi track and a gaming track, right? And it's an intense like 8-week program. And after our first kernel block, we had like a bunch of companies, like 10 million in funding, like two months after. But a lot of the other companies and small things that were started, especially infrastructure, like public good type projects, were great candidates to open up a grant. So, you know, we tell them a couple weeks before, get your grant open, proof it, share it with some friends, but tell them that like the matching starts on this day. And we will see some people will donate like out of the matching round. And then they're like, why didn't it match? And to us at first, we were like, it's obvious. Like it didn't say it was matching anything. Why do you think it would get a match? But we're actually updating a lot of the UI for those types of questions that come in. But yeah, you can put it up anytime. No beneficial boost. But we did see, and they cover this in that video that I posted to Discord, is an interesting thing is the placement on the page. So like different random stack weighting and stuff. We actually did an A/B test on it. So like if your ID number was even, you were in group A, and group B if it was odd. And so everybody who visited the page, they got a different sorting, and it showed that there were tangible benefits to certain groups based on the sorting. So we want to find answers to stuff like that, as well as simply Sybil resistance.
Cool. Yeah, I think there has been a lot of testing on the interface. So I guess in every single round we have new elements on the interface, and I think this also probably should be taken into account when looking at the data. Perhaps we can dive into that at some other point in time, perhaps later in the project. But I guess there's a lot to be told about your experiments you have been running on making this fair for everyone, making it transparent, and so on.
Yeah, there's definitely a lot of lessons, and some of them we are forced into iterating solution for.
Yeah, I guess so.
Yeah.
Any more questions on Gitcoin Grants so far? Okay. All clear? All right. Then let's take a closer look to Quadratic Funding. Joe mentioned it. There's a book. I don't know if you've read it. It's Radical Markets. It was published in 2018, Glenn Weil and Eric Posner. And this book introduced radical democracy and the concept of quadratic voting. And below you see an article on radical markets from Vitalik Buterin, published in early 2018, April 2018. And he commented on the concepts introduced in this book. And obviously, I'm not sure if this was his first, let's say, time looking at the concepts in radical markets. Nevertheless, he's at that point saying there are a lot of there's a lot of potential in concepts like quadratic voting for the crypto sector. And it didn't take long, December 2018, this paper Joe already mentioned was published, Liberal Radicalism, Flexible Design for Philanthropic Matching Funds, which is then outlining Gitcoin Grants funding and the concept behind it, Quadratic Funding, published by Vitalik Buterin, so Hitzig and Glenn Weil. And to understand the theoretical concept behind quadratic funding and Gitcoin grants, this is certainly the place to go to, the paper to read. And I think we should have a dedicated session and presentation on that. We can discuss that later on, but yeah, definitely read it. And so to summarize quadratic voting, it's basically a mechanism to solve the problem of public decision-making. Since traditional markets, you can have individual choice and individual decision, but it's not a good mechanism, or it's not even able to solve funding and decision-making for public goods and signal a common choice. And so quadratic funding combines the number of votes here on this chart on the y-axis, number of votes, with the strength of support, which you can see on the x-axis. So any voter can make n votes, but at the cost of n. So any additional vote will cost you more. And this is the combination of number of votes and strength of votes, which is behind quadratic voting. And then there is this next step, quadratic funding, where you can have not a limited number, but any number of proposals in the ballot, which is in Gitcoin Grants case also an important prerequisite. We want to have permissionless access for Gitcoin Grants, so we never know how many grants we will have in the ballot in each round. It's in a way an individual provision of public goods and matching funds from a central subsidy pool, the matching partners. And the turnout is in any case larger than the sum of raw contributions. And this chart, this picture here on the right, is providing a really nice visual explanation. So you have the square root of contributions here. You have smaller contributions from individual supporters, larger, smaller, larger, whatever. And we have the sum of square roots, and the green areas are the individual contributors matched with the yellow area, right? The matching funds. And this creates benefits, but also challenges. And quadratic funding is sensitive to colluding grants and contributors, which is the key question Danilo is at the moment diving deeper into with this optimality gap, which we will discuss in a second. ID fraud, of course. So a single citizen might represent himself as many. And perhaps, I think we don't have a final solution here, but it's also, we think it's also worth exploring the Matthew effect, rich getting richer in Gitcoin Grants. And on the challenges for quadratic funding, we had, or discussing the challenges, we had an academic discussion last week. So some more context. We will run, throughout this 8 weeks, we will run meetings in the research group, hacking sessions with Danilo. Next one is taking place tomorrow. And academic discussion, which are bi-weekly on Thursday. Next one will be next week. And this is a recording of the academic discussion last week. And I just want to show you a snippet where Jaja, also a member of the Block.Science team, were well, sharing some thoughts about the challenges in quadratic funding. Now I have to switch briefly to video. Let me share my screen again. All right, you should see the YouTube screen now. Can you? Okay, just a couple of minutes, quite interesting aspect.
One more slide, sorry, up. Slide number 6, yes. So, like basically, this, as you can see on this quick visualization, the ways of quadratic funding, the default quadratic funding work is that you take the square root of each contribution and then you add them up and then you take the square of that. So in this visualization, the square, each green square is each contribution. You take square root, which is its diagonal, and you add them up. It's the diagonal of the big square, and then you take square, so it's a large square. But this visualization makes it pretty easy to say that if you reduce if you increase the number of green square, you would eventually have more and more yellow area, which is a matching fund, and less and less of the green area, which is the original contribution supposedly by the crowd. So this kind of leads to so there's like different types of collusion problems, and one of the very easy to do one is basically divide yourself's grant to like tiny green squares, so that you will basically attract a lot of matching funds, but with a limited amount of input. So if you don't mind going down to slide number. If you don't mind to go to slide number 15. So of course, one way to deal with that is the solution proposed by Vitalik. It's called Pairwise Funding. So as you can see, kind of looking at the red circle there, you can see instead of saying the red, the yellow part as its entirety, you see this tiny yellow square as a match between fund I, which is one green square, and fund J, which is another green square. So if you like add if you add a parameter to it, then potentially you will be able to identify if people are kind of contributing to multiple funds, but with like a bunch of like they try to coordinate small funds that contribute to a specific subset of funds. But the problem with this type of detection If you don't mind going down one more slide. Is that potentially it is like punishing the collection features, which encourage people to donate to a pre-selected collection of funds. And those are just two cases of potential ways of collusion and detecting collusion on a individual levels. And one of the trends that we see in the past few rounds of Gitcoin funding is that potentially the funding collusion is going more and more complex. And the way to deal with that complexity, if you don't mind going to slide 21. One more. Is that the problem with that is there will be a more and more complex way of preventing collusion, but potentially you would have to design more and more complex way of detecting and preventing collusion. And this basically leads to the escalation of collusion and also creates more and more information asymmetry for people who have the motivation to detect collusion, to learn about new ways of collusion, and people who don't. Can you go down one more slide? Thank you. So there's already kind of evidence showing that most users that use Gitcoin don't necessarily understand how like quadratic funding works, let alone like pairwise or like this more complex way that we're proposing to detect collusion. And the problem with that is the people who are motivated to understand collusion or like new ways of collusion are usually malicious actors. And can you go down one more slide? And people, so basically you are creating information asymmetry, and only people who are motivated to understand the information are those who have malicious intent. So what would happen is that the game would not stabilize itself, but instead only people with more information are more likely to game the system than people with less information but good intent. So credit to Joseph Hong to suggest kind of using more simple mechanism to balance the meta game. Because if you have a very simple and transparent way of detecting solution, or if you can make your way of detecting collusion very understandable to all of the users in like a very short time, people would know what would happen if people collude, right? So the idea is not to know how to collude or know how, or not knowing how to collude. Is I know that you know that I know how to collude. So basically, if everyone understands what the strategy of collusion looks like, there would eventually evolve a balanced game where people know who is colluding, and it's easier for the community and the crowd to catch collusion.
So I stop here. I'll share, or we have a collection of all the recordings of these sessions, so feel free to watch the full talk and presentation here. But what actually Jaja is talking about, and which is in a nutshell many aspects of this project, making quadratic funding better means we look at collusion, we try to prevent collusion, we try to prevent ID fraud, and we should be able to better understand Matthew effects. But then once we try to find out what is collusion and try to define collusion and try to find mechanisms to prevent collusion, we also have to keep in mind that this might increase complexity, this might cause information asymmetry, and then has also side effects we don't want to have in the system. So some aspects to shed some light on what already took place in the Block.Science project. Now, perhaps we should go for questions. So any questions so far on quadratic funding, on the findings so far?
Yeah, so
Um,
Jay, go on.
I'm sorry, I have a very simple question for Joe. I'm trying to just make a list of the different kinds of problems that you're looking at. Do you guys have a list of sort of all the problems that you have with quadratic funding so far? Sybil, the Matthew effect, ordering on the page, just like a list of what the problems that you're working on are.
Yeah, we have kind of a couple that have to be brought together. We have like our product list, and then there's like our research list, which is a separate, although the product stuff does need to be researched, of course, and crossover. Let me see if I could just put a few things together and give us a good doc for that.
Cool. All right, anything else?
Yeah, I was just asking, were there any real case scenario that actually happened with the Gitcoin grants where there was a collusion or something that you detected, or some real case problems that you really saw that they were happening in the matching round or somewhere?
Joe?
Was that directed to me?
Yeah, again.
Say that again. Sorry.
Yeah, sure. So I
I was
just
looking for the thing from the last question to drop in the link.
it's just a bit connected with that question. So I was just asking, were there any real-time situation or circumstances that arose in the funding in Gitcoin grants that you found that there was some collusion or some way that it was being gamed?
Yeah, so here's a few of them. One of them is just a direct like quid pro quo kind of thing. Like we're gonna do an airdrop, and you'll get airdrops if you donate. One of the interesting things that we did was we made our data open so people can query all the addresses that have donated to Gitcoin grants, and we think that's a virtuous cycle. Like you basically get rained airdrop karma because airdrops want to drop tokens to an ecosystem of developers. It's just smart for them. It's good. And if you have donated before, you might get donations, but we don't allow, and this is where we slightly differ from crypto economics, which I love Vitalik Buterin's answer to like Tyler Cowen. He said like crypto economics is just economics, but there's no room for subjectivity. We have room for subjectivity a little bit. We're not fully decentralized in everything. And one of the ways that comes up is disputes of what is a legitimate grant. So anybody can make their grant. We are looking at different measures on how we can use different mechanism designs to facilitate either curation of the quality of grants or even dispute resolution of, is this grant allowable? And as of now, it's really like on the back end, we say this isn't allowed to get matching weight. And examples might be like one where we were really worried about it was like, yeah, we were aiming to get more groups from outside, like US, North America, Europe. And we did a Southeast Asia matching round this last time and went pretty well. But we had one group that it really looked like it was non-human like traffic. So we looked in and then found that they had a telegram where they were telling people that they would give them something. But they saw that Badger DAO, a group who was the matching pool, was telling people go donate because we're doing this drop. And it was totally different because, and I think after talking to them that they were honestly trying to do that, but that's one of those things we would like to take out of our hands and use a dispute mechanism like a Kleros or something like that. But that's a very difficult one as opposed to other kind of quid pro quo situations where they're just straight out saying, we will give you this if you give us that. So that's probably the most in your face kind of problem that we see. Yep. Outside of the fake accounts, right? One person donating from 10 different addresses. But that's where we have the, if you look at the page for grants, there's a thing called the Sybil Score. And we ask them to do different things to kind of verify themselves as a unique human. Like you could go and make 20 different Twitter accounts and verify yourself as 20 different people. But at some point, like the little extra matching benefit you get is not going to make that worth it. So we just need to make the cost of corruption or collusion higher than the cost of not colluding.
Okay. Anything else? No, not at the moment. Then let's go to the research project and Block.Science. And I hand over to Danilo.
So I'll give a brief overview of what is Block.Science. And well, this is important because let's say on this research ecosystem about Gitcoin and so on, we've been sort of leading that open science project with publicly working sessions and so on. We've been building models that allows people to, let's say, to test counterfactuals, to test different mechanisms. So it's worth to talk about this research project because let's say I presume that a lot of you are going to maybe to consume the specifications that we wrote, the models, and I think that this will make life a lot easier when doing tactile research. And also, let's say we already have several questions that you could take. But anyway, about Block.Science, we're an engineering and research development firm. And essentially, we are specialized in, let's say, modeling and designing complex socioeconomic systems. So, for example, Gitcoin is a socioeconomic system in the sense that, let's say, it does provide economic allocation for people, but at the same time, let's say, you have all these social iterations. But we also provide consulting to, let's say, to token economies, to applications that develop on the crypto space, and anyone that needs, let's say, decisions informing in complex models and designs. And when I mean complex models, you are talking about agent-based models that can use dynamical systems, or maybe systems that depend, let's say, on complex networks. So it's really about having models that combine a variety of paradigms. And we've been on the, let's say, we are some of the pioneers on the token engineering arena in the sense that, let's say, the idea of that you must have engineering process for developing tokens, for developing the economy of that tokens, and that also, let's say, that the flows of that tokens, let's say, must make sense for the social actors on it. The idea that, let's say, we could have an engineering mindset and that we could, let's say, engineer tools and simulations that could provide insights to us to build a sustainable system was one of the things that motivated the foundation of Block.Science. And let's say we've been in close touch with Angela and a lot of other people for some time. And the tool that we usually we utilize for creating our models and so on is cadCAD. And this is a Python package, is open source. There are several models over the crypto arena that uses cadCAD for, let's say, for doing projections for the future when you have different mechanisms or for integrating with live data. There is really a variety of scenarios. And for Gitcoin specifically, we have built a cadCAD model that, let's say, consumes the historical data, and it could consume the live data too, if we build a pipeline for that. By using cadCAD, we could test, let's say, how Gitcoin would behave if we adopt, for example, a new feature in regards to the quadratic funding, or if we drop the quadratic funding and just use a simpler mechanism, or if we use a different version of quadratic funding. What I mean is that, let's say, cadCAD makes it very easy to you to test, let's say, the system on the different assumptions and also different parameters. And it's a thing that probably we are going to use a lot. And well, that model was developed, let's say, about 3 months ago when we had our Kickoff research project with Gitcoin Grants. So the way that we've been proceeding with Gitcoin, and I think that we could go to the next slide, Yeah. So the way that we've been going is to, let's say, from November to December, we built that cadCAD model that allows us to explore different counterfactors for the network and so on. The idea of the collaboration between Block.Science and Gitcoin, the main topic of interest to us in that specific collaboration is to investigate collusion as a complex phenomena on Gitcoin grants. And when I mean complex phenomena, is in the sense that collusion at its core is a private intent. In the sense that, let's say, there is no, let's say, absolute measure of what is collusion. It's a subjective value, and this requires, let's say, a more complex approach to it. And I'll talk about it soon, but we've been proposing some metrics that, let's say, capture some of the features and also some of the desirables for a metric, like, for example, turning the cost of corruption very high, so it doesn't really is worth to be corrupt. But anyway, the way that we've been proceeding as Gitcoin is, let's say, is a open source platform for empowering also open source projects, is that our research is also being made open source on GitHub Repos. And the idea is that, let's say, when we build those cadCAD models, when we write our specifications, we also make it available so that people can create open science based on it. This is a key rationale, for example, of why we started to do those public working sessions. And to be, actually, we're going to talk in 3 slides about that. But anyway, our last point about that project and how people could use it is that, let's say, we have had the Gitcoin grants data available for consuming. They are anonymized, so it's on the GitHub repo. We have data for the round 7 and 8 for all the contributions over Gitcoin grants. And if you want to, let's say, to touch on that data, now you can. You just go to the repo and there is a folder called data, and it's a CSV file. There is also a head model that you could use for, let's say, test a new mechanism. There are some notebooks that you could use for inspiration so that you could test some metrics that may be of interest to you. And I think that we could go to the next slide.
All right.
Given that, I've already talked a bit about the cadCAD model, but the idea is that, let's say, we have this repository on the Gitcoin co-organization, the Block.Science organization, that repo that is the Gitcoin cadCAD model. And if you enter on that repo, there is going to be a folder about called model that contains a cadCAD model where you pick, let's say, the event sequence of all the contributions on Gitcoin grants, and it calculates metrics for any event that you would like. You could calculate, for example, metrics for contributions events or maybe new grants events. But right now, what we do calculate is, let's say, is we get the sequence, we calculate the quadratic match as implemented right now by Gitcoin. We implement also this, what we've been calling the simple quadratic match, because the quadratic funding schema as implemented now is let's say, is a variant of the original proposal in the sense that you have a term that people call the pairwise totals comparison. There are some nuances that, but anyway, one thing that we've been investigating is, let's say, how those 2 implementations of quadratic funding would compare themselves when provided the same data. And there is a third also metric that we've been calculating for each grant, that is, let's say, the linear funding, which is essentially $1 given amount of match. It's the simplest match that you could do. You have those models, and also you have notebooks that consumes the data from that model and gives you some metrics, like, for example, the total amount, the total contribution, how is the Gini coefficient across grants and across contributions. So it's very straightforward also to get on that kind of metric. And also, there are some notebooks for some specific research that we've been doing, like, for example, about the optimality gap. And we could go to the next slide. Just to, let's say, to keep you all in the loop of what we are doing now. we have a research plan for, let's say, for the current iteration, because the way that the Block.Science works with Gitcoins is through research iterations. In the sense that, let's say, on each iteration, we create a plan. We create, that research plan follows a scientific workflow in the sense that you would have an introduction that tells the rationale of why we are investigating that, what are the nuances of that, of the phenomena that we are investigating. And the specific topic of our research is collusion, and how you describe collusion. So one thing that we've been using to guide our research plan is the idea that, let's say, because pick a graph at handle, you pick, let's say, the grants that you have on Gitcoin and the users that donate to it. People usually donate in an organic way, in the sense that, let's say, they have some friends and donate to the friends, or maybe they got the word and donate to it. There is some randomness in how people choose to give a contribution to a grant. And the idea is that, let's say, if you pick an actor that is a colluder, he's going to have a different approach. The contributions of a colluding grant is not going to be let's say, very random. It's actually going to be very optimized in the sense that the collusion, as is, let's say, is an intentional action, it is articulated and planned. So one insight that we've been using for, let's say, creating something that could measure collusion is the idea that, let's say, some grants are more optimized than others. Let's say, if you have a metric that tells that a grant is very optimized for the contributions and another is not so much optimized, then most probably the grants that are colluding are going to be very highly optimized. And we tell that on the introduction, and given that, we propose a hard definition of that idea, the idea of optimality gap. So the basic idea is that, let's say, on this research plan, we want to know what is the distribution of the optimality gap on Gitcoin, on the Gitcoin rounds data, because we don't know. And actually, the point on doing research is to actually generate knowledge about something that you don't know. So we have a research plan where, let's say, we put the definitions, like, for example, we have the optimality gap that is defined in that way that, let's say, you pick a grant, you pick the community around that grant, and you try to optimize that graph. So let's say you get the match when the grant is not optimized, and also you get the, let's say, the match when the grant is optimized. So in essence, it's a graph optimization problem that, let's say, you reward the collaborations and get the best possible match that you could. And yeah, that's so. Just to be clear, given this, just to lay out what is the standard scientific workflow, you have an introduction, definitions, hypothesis, methodology, applications, and next steps. So I was giving to you the introduction and also a bit afterwards, but anyway, the idea is that let me see the best. I think that you could go to the definitions.
Okay. All right. Yeah.
Yeah. So giving, the way that we are expressing how we define those concepts that I left out is first, what is a community around a grant? You can have several definitions for that. The definition that we are using for this iteration, and of course, when you are in a scientific process, you can always change the definition afterwards. But anyway, the definition that we are using right now is that, let's say, the community around a grant is essentially to take, let's say, the neighborhoods of that grant given a certain distance. So let's say you get a grant, you get everyone that donates to that grant. So this would be sort of analogous to figure expense one. So the blue node would be the grant, and the red one would be the people that have contributed to that grant. And then we select all the grants that the people in red also has donated. So this would be expansion two. So the blue one would be the original grant. The green one would be, let's say, the neighborhood grants. And then we also select the people who have donated to those neighborhoods grants. So that would be expansion 3. So nodes that are blue and green would be Gitcoin grants. And nodes that are red and purple, they are contributors. So for each grant, we define the community of that grant as being that. And I mean, this is just a definition that we've been using for doing that first iteration. And I mean, depending on the results or depending on how successful they are or I mean, how not successful they are, we can change that so that we can use more sophisticated ways of detecting communities. But anyway, that's the definition. Scroll down a bit. So, and here we have introduces several other definitions, like, for example, the idea that a subgraph or a community can have a quadratic match. So, I mean, if you take the quadratic match of the expansion 3 subgraph, essentially you are taking the quadratic match of all the grants that are contained inside of it. So it's the quadratic match of the original grant plus the neighborhoods, the grants that are neighbors to it. And if you go to D4, I define, for example, what is the Hill subgraph? So the Hill subgraph is, let's say, you get the data, you get the subgraph for a given grant, and well, that's it. But the thing is that, let's say, in order to calculate what we've called the optimality gap, we also need to define D5, and this is going to be a bit more complicated in the sense that, let's say, we pick that Hill subgraph, we pick the original subgraph of the data, but we start to rewire the edges. So show the figure below. So the idea, let's say, suppose that the Hill subgraph is just like letter E. The idea is that, let's say, we want to change the connections in a way that we maximize the quadratic match going to that subgraph. So subgraph, oops. And I mean, we optimize that, we get the best possible arrangement, the best possible value. And by having the best possible match and the Hill match, we can calculate the notion of optimality gap. And optimality gap captures the idea of, let's say, how far away is that community of that the community around that grant is far from being optimized. So the optimality gap is a number between 0 and 1. When it's 1, it means that, let's say, the grant is very terribly optimized. Actually, it's not optimized at all. There is no degree of optimization. And to be true, most of the grants actually have optimality gap between 0.8 to 0.6. But I mean, if you have optimality gap of 1, it's a very inefficient grant. I mean, if a grant has a very huge optimality gap, it means that, let's say, probably the colluders are going to have a lot of expenses because it does not have optimization. Or the colluders aren't professional because they didn't articulate well. If the optimality gap is close to 0, it means the opposite. It means that, let's say, the grant is very highly optimized. And actually, if it's equal to 0, it means that it couldn't be better. So we have a hypothesis. I mean, strong emphasis on the hypothesis because this is how science works. You lay out explicitly what you think, what your hypothesis is, and you try to disprove it or not. And the key consideration on creating any research plan is that, let's say, you can only do science when you have a falsifiable hypothesis, in the sense that, let's say, you must have affirmations that it's possible to make false. You can never prove anything, but let's say the important thing is for you to be able to make it false. And the thing about this hypothesis that we have laid out is that it's easy to make it false in the sense that, let's say, our hypothesis that if you get the optimality gap for all grants, and you get a histogram, you get the distribution of that, our hypothesis is that it's going to be B model. And show the first figure of that HackMD, the introduction. The first one.
Here? No.
At the beginning. Yeah, that one.
That one.
So our hypothesis is that, let's say, suppose that the horizontal axis is the optimality gap and the vertical axis is the number of grants. our hypothesis is that, let's say, we're going to have a very large cluster on the high side, in the sense that most of the Gitcoin grants are not going to be optimized. But we have also another cluster that is closer to the low optimality gap distribution that we suppose that, let's say, could be interpreted as candidates as colluding grants, in the sense that, let's say, they are very highly optimized. So in a certain sense, we are sort of looking into the consequences of what happens when, let's say, you are a successful colluder. So, I mean, you could still, let's say, trick that by being a bad colluder, but I mean, if you are a bad colluder, most probably it's going to be costly. So, I mean, I think the important thing is to have a hypothesis that allows us to flag some way what could be good candidates for good colluders. A good colluders in the sense that, let's say, they are being efficient on performing the attack. And given that, we can go to the applications of that HackMD.
Should we go back to the slides or to the repo, or what's best?
I think that to the applications.
In the document, all right.
Yeah.
Okay.
So one of the things about our research is that, let's say, we have a series of applications and next steps that we could do if the hypothesis is true or false. I mean, if the hypothesis is true, this means that, let's say, we could potentially have a policy that allows for human evaluation of certain grants. If the grant is very highly optimized, then this means that, let's say, maybe it's worth it to flagging that so that we could look better. But if the hypothesis is false, then what we can do is, for example, we could change our definition so that we will use community detection algorithms instead of the neighborhood subgraph. We could also test another hypothesis. Instead of testing for bimodality, we could test maybe for spectral separation. Another way would also to change the metrics, in the sense that, let's say, we could change our definitions and look into another candidate for the optimality gap, or we could optimize for more than one metric. And in any case, even if the hypothesis is true or false, we can have next steps that we could do anyway, like, for example, testing optimality gap when we have, for example, when we look at the temporal evolution of the network. So instead of looking at just a static view of the network, we could, let's say, try to expand that into temporal windows. We could try to use also the optimality gap to evaluate and give insights for the next grants round in lifetime. And I mean, there are several things, and that's why I put on the last bullet point that there is a world of size out there to explore. So, I mean, this is the context of the research plan that we are doing right now, and that we expect that let's say, maybe it will be the topic for some months. And I think that we could go to back to the slide.
Okay.
Yeah. And
right, let's, oops. I'm here in a second. Sorry, I can't find my slides anymore. We'll be back in a moment. Yeah, this is the research plan. This is it. Okay.
Yeah.
So this is the research plan. We already had that. Oh, yeah.
Yeah. And a key thing that we've been doing for the methodology of that research plan is that, let's say, on that iteration, we laid up a plan for doing open sessions, in the sense that, let's say, we have those hacking sessions where we have an agenda and we get for 2 or 3 hours and we get to live coding. So, for example, we had a hacking session where we actually get the definition section of that HackMD document. We put let's say, on a side, and on another side, we got on VS Code and we start to write Python code encapsulate those definitions. Another hacking session that we had was for example, implementing the optimizers that we require for calculating the optimality gap. So we forked the network X library. We wrote the code for create a hill climber optimizer and also a simulate annealing optimizer. And also we send a pull request. we almost got into a final result, but there was a final bug. And I mean, this is a thing of the hacking sessions. It always ends with a cliffhanger. I mean, it's super fun. It's going to have one tomorrow if you guys are available. I think it could be super productive if you want to, let's say, get the feeling of, let's say, how is the actual process of implementing scientific workflows. And there is also the academic discussions that the idea is to have more, let's say, a more top-level discussion of the research directions. So the idea is to, let's say, is to get in touch, for example, with the Quadratic Funding paper authors, to get in touch with Awaki from Gitcoin, with us from Block.Science. And the idea that is, let's say, we could discuss anything that we could find potentially interesting for the Gitcoin ecosystem and the Quadratic Funding algorithm, in the sense that, let's say, what are the things that are worth exploring? What are the results that you got into? So it's really more of, let's say, of an academic meeting. And I mean, I think this is it from my side. I would like to know if you guys have any question, or if you want me to dive in deeper into a specific topic. And yeah.
All right, shoot your questions. Whatever.
I have a question. So the definition of optimality gap seems dependent on finding the optimum with respect to this utility function. But you're finding this through simulation, right?
So
do you have
right
any
now,
indication? Go ahead.
No, go ahead.
So do you have any indication how far, like what the true optimum might be?
Okay, so I mean, this is the current thing that we are working into. So right now we are using a hill climbing optimizer. And what you need is to do thousands and thousands of simulations. And one thing is that, let's say, when you get, let's say, how much the optimality gap changes with time, is it has some dependency on the number of iterations, but it's not a linear curve in the sense that, let's say, if you have, for example, 5 iterations, you are going to have a very high variance when you try several times. If you try 1,000 times, then you have a lower variance. So, I mean, this is sort of an open problem in the sense that, let's say, I think there are several things in there. And I mean, this could be an interesting research problem that you guys could tackle if you want. So one way of tackling that, for example, is simply by doing lots and lots of simulations. And in order to do that, you need to have a fast algorithm so that you can have lots of iterations quickly. I mean, there is a problem with the quadratic funding algorithm that it has a quadratic complexity. So quadratic funding and also quadratic complexity. And well, this is a bit bad when you need to do some thousands of iterations. So for example, one possible research direction would be to create an iterative way of that algorithm so that it reduces the linear complexity factor. And this is possible. Actually, we started to lay out how to do that. But anyway, this could be a topic that could be interesting for you. Another way of approaching would be to adopt a more, let's say, a more formal mathematical approach, in the sense that it may be possible to deterministically, in a deterministic fashion, know what is the optimal arrangement. This is also an open problem. We don't know the answer, but I mean, it's another interesting topic. Did it answer?
Yes, thank you.
Any other questions for the moment? I think you'll all get more and more into it. Visit the hacking session. It's really a great chance to see how you implement the algorithm in cadCAD. What's the best implementation? Then new ideas coming up on how to shape the model and use the model. So this is, yeah, step by step, I guess. We will come closer then also to your personal research question. Any other things so far on the goal of the project for Block.Science? perhaps we can check this out as well. So for the research group, our goals are that you gain a deep understanding of Gitcoin grants. So this is not the only session we will discuss Gitcoin grants, certainly. And then based on that, define your own research question, week 3, the latest, and you work on that and deliver results. With deliver results, this is not in terms of, okay, we have to find the final answer on optimality or on the utility function for Gitcoin grants, but rather you make progress in terms of your research question. And ideally, of course, provide new angles to improve quadratic funding, or perhaps new solutions, potential solutions. But in any case, you work on your research question and deliver results. It's not only listening, it's working and producing output. And then, of course, overall scope for everyone, this research group, Block.Science as well, Gitcoin to improve Gitcoin grants and progress the funding of public goods. And this is not only then Gitcoin grants, it's the overall how to fund public goods, which is a huge question for open source and for the Web3 sector in general. And we want to shape this in a fashion, open science, sharing, collaborating, creating value, providing open source repos, writing about your findings, about your thoughts, can be sharing notes. We are recording the sessions. The hacking sessions are open to everyone. And so this is our work will be accessible by anyone in the Web3 ecosystem. And of course, you will gain visibility in the Web3 ecosystem. Now, regarding research questions, expanding on optimality gap, and how to signal collusion. So as Daniel already mentioned, what happens if time is introduced, if we are not analyzing a static system, and using community detection algorithms. Daniel, maybe you can, how do you define community detection algorithm? This is something that's not really clear to me as well.
So as I was saying, right now we are, let's say, we are calculating the uplift gap for each grant.
Mm-hmm.
And when we calculate that, we are getting, let's say, the neighborhoods of that grant. Because we suppose that if you take that neighborhoods, this could be an approximation for overlapping communities.
Okay.
But this is not the only way of doing that. And I mean, exploring, let's say, the variety of ways of that you could use for the defining community could be an interesting problem. And I mean, it's a very open-ended one too.
Yeah, true. And then there are other things to explore. Maybe you continue, Danilo, on alternative research questions.
Yeah, I can go on. Just a disclaimer that this is a non-exhaustive list. This is just some quick suggestions that we have. But I mean, you are all free to investigate things that you would find interesting. But for example, the first one is to see how quadratic funding compares to any kind of alternative. So for example, one discussion that we have on Discord is, what if instead of quadratic funding, we had cubic funding? So, I mean, I don't know, we could test that. And if you, for example, you have some utility metric and so on, you could even get more objective about, let's say, how quadratic funding could be better or worse, or maybe into different scenarios. Because, I mean, you can also test different scenarios. You are not restricted by only the Gitcoin 178 data. You could, for example, introduce vectors and so on. So this could be a direction. A second direction would be to also see, let's say, how the funds are allocated. In the sense that, let's say, I think that the most obvious way of visualize that is, let's say, what is the Gini coefficient among Gitcoin, among people that participate on the Gitcoin economy? And I think there are several ways of how you define that, because even when you talk about Gini coefficient, you can talk about, let's say, you can talk about contribution, you can talk about let's say, amount donated to a grant, or maybe a cumulative amount. And also there are some ways of also investigating that, let's say, you could also try to think how this integrates, for example, with social network metrics, how this integrates with the popularity of a grant, or maybe, maybe integrate with Twitter. I think that there are several, let's say, complicators and integrations that we could do when investigating that question. A third one would be a more basic science-related one, in the sense that about network formation. That is, let's say, how is generated that contributor network? In the sense that, let's say, what makes a people to donate to a given grant and not to another? There is any pattern? Can you use any data to explain that? So, for example, one hypothesis that we have internally, but in order to investigate that, it would require time, is that, let's say, we suspect that the grant behind the Gitcoin Grants contributions graph follows a Barabee preferential attachment model. And there are some implications to that. But anyway, in order to, let's say, investigate if that's exactly true or not, and what are the implications, could be a good research proposal. A fourth one would be to do some analytics when the network is saturated. In the sense that, let's say, when you pick the quadratic funding algorithm, the match for the projects only goes up until you reach the total pot for it. Once you get at that point, as Joey has put it, it becomes let's say, a negative zero sum game. So one investigation is, let's say, what happens when you get at that point? How this modifies the dynamics of the network in regards to before that? Or then, let's say, how much because people a lot of times they do some contribution expecting that, let's say, because when you go to the user interface of Gitcoin, you are going to donate to a grant, and you have the following, you always have that message. You give, let's say, $1, the project is going to receive, let's say, $100. But the thing is, that message is based on the current status. How much does this changes with time? How much this interferes with the decision making of the users? So that could be another front. And the last front that I put here, that is alternative signals for collusion, is that, let's say, right now we are using Top-Limited Gap as our proxy, but I don't think it's the only proxy, and there are other signals that we could also think about. Maybe, let's say, some kind of extraction metric, but it's nothing that we could think about. And those are some ideas that we have laid out, but as I said, this is not exhaustive, and you can, let's say, treat that as a brainstorm inspiration, but feel free to think about anything that you would like to know about the Gitcoin system, or that you think that people would like to know, or that you think that could affect, let's say, the directions of Gitcoin so that it can become more sustainable in its purpose. And yeah, that's it.
Okay.
I also put a diagram. I don't know if it's on that slide or not. It would be the next one.
Yeah.
Yeah, I put that diagram just to, let's say, to maybe provide sort of a map in the sense of, let's say, what we as a Block.Science are doing, what have done and are doing, and also some how this could integrate with some of those tasks. So, for example, if you see the yellow box, the data and cadCAD model work done previously, those are things that are already on the repositories. If you want to get, let's say, if you want to touch that right now, you already have access to it. Oh, the yellow one, yeah, it's above. Actually, the orange one are other things. The research plan that I have described to you, that hacking ED, is about the gray box, the top gray box. And to be fair, most of it is already implemented, so you can treat it as sort of a yellow now. But also, let's say, we intend to dig in deeper into that, in the sense that, let's say, we want to be more sophisticated in regards to how we define that optimal rewiring problem. We want to use different community detection algorithms and so on. So, the below gray box there scope is sort of what we expect to be our next iteration. And on the orange one are things that we are not going to touch, but that we think that it could be very interesting for both beginners and advanced researchers in network science. So you could, for example, test other different kinds of metrics like the Navy ratio. You could explore the Gini coefficient, the Penland fitting, how everything of that fits into fairness considerations. And I mean, that's it. This is, as always, this is a non-exhaustive map. It's just to, let's say, maybe providing some inspiration. But yeah.
And I guess next Tuesday, we will have our next session, and this will be a workshop to discuss your ideas for a personal research question. And I guess what I think the general structure we should keep in mind is that just brainstorm whatever is really interesting and relevant for you. And then the next step is to formalize this in some way, to be able to simulate it, to build a model, and then use the data, if it makes sense, use cadCAD and create insights based on that. So this is the general steps, and you can also check out Danilo's document because it provides a very nice structure, and ideally you would have a similar structure for your own work on your own research question. I guess this is viable to take this as a template, Danilo, right?
Yeah, I think that, let's say, one of the main intents on having that is really to, let's say, creating an infrastructure and a template that allows to make more easy to actually take part. And I mean, of course, you are all welcome to use any tools that you would like, any structure that you would like. But let's say we are trying to make it as easy as possible. Let's say if you guys, let's say, just want to fork and put more commits.
Cool. And now we are coming to the final part of this kickoff. And these are some logistics and general information. So what I would like to mention is working in the token engineering community. So we have learned a lot over the last 2 years. And one of the most important findings is that this is really a multidisciplinary area where we want to have people from different backgrounds working together. And this is extremely important for token engineering, since we are here combining technology with social aspects. We are combining technology with irrationality and human factor. We are combining systems engineering with psychology. So it's natural that your co-researchers coming with different mindsets, with different terminologies. And this is actually, it's on one hand, it's a challenge, because sometimes you might, just talk a different language with your co-researchers, but it's also a superpower, because this is nurturing creativity. And this is helping us to come up with really exciting solutions that can't be developed in any other sector. So let's take this as a challenge and a superpower. And our solution for this, there's nothing else than asking questions, asking questions, asking questions. So you might run into situations, endless situations, where you think, I don't really get this optimality gap, or I don't really get, what is he talking about? We had this morning where we discussed the term atomic. And of course, you can define it from a software engineering perspective. It's different from physics, and it's different, again, from storytelling. So there is really, asking questions is our superpower. Don't hesitate to ask for a definition. Don't hesitate to ask for, okay, I have to check this out and come back. And in addition to that, throughout the 8 weeks, we will have sessions where we run presentations, and every one of you should have one presentation to introduce a certain model or mechanism you find interesting. perhaps related to your research, or a certain term or definition or a certain perspective, a certain theory, a certain paradigm from your own discipline that is relevant in this context, so that we just educate each other and let's leverage this multidisciplinary group. So you are invited to look at the challenges through your own lens, through the lens of your discipline. Team up with others from other disciplines. So if I say your individual research question, that doesn't necessarily mean you have to work alone. You can work in teams. And to let's say, make the most of collaboration, always be prepared to provide context, to provide a further definition, background knowledge, to help others making progress and looking through your lens, right? So this is important to keep in mind, and you are never wrong with ask any questions. So I can't, we can't have too many questions, and therefore this is the right attitude in our sessions. So yeah, let's get back to this whenever you need further information. Now, we also were trying to give you a good picture of what is successful participation, since you are asked to stake on participation in this research group. So we expect, or we have an estimate that a good time investment for this research group is 10 hours per week on your own schedule. At least one presentation. If I say initial presentation, means it provides basic understanding. For example, we will have an open schedule and several slots. You can provide a session about quadratic funding, fundamental understanding on the paper. You can provide a session on path edge rewiring that we need for optimality gap analysis to make this understandable for everyone in the group, and also inspiring for additional analysis. It can be everything that helps this group to make progress based on your ideas and also based on your questions. So ask your team, your team members, your co-researchers for, okay, you seem to have a good understanding of this, I need this, can you please provide a presentation on that? Then results, as mentioned, delivered on these research goals. So produce output, not only listening. The results, your results should be shared in a presentation or written article at the end of these 8 weeks. We will have a date, April 2nd, where we have final presentations, which will be public. And it can be also alternatively, or in addition to that, a written article, which makes it even easier for others to get back to your work and build on that. And yeah, we expect everyone in the group to attend presentation, hacking sessions, academic discussions. However, the results on your research questions are more important than attending every single session, and we will record so that you can follow up in your own speed, just on a side note. And on every, on the presentations, on the articles, on your research goal work, you can work individually or in a team of 3 at max. Okay, what else? Yeah, questions on that? Good. All right. So we will have a session on Tuesday where we brainstorm on research questions. So no problem if you feel, oh, I don't have one at the moment. And there will be a lot of inspiration throughout the upcoming weeks. I promise. Now, logistics. Here's our one-stop shop document. I will now switch to my, okay, you should see it now. Wait, that's not the, that's the wrong one. Okay. You'll get this link in a second, shared on Discord. This is everything, all the links you need to have for this project. So the contact people accessible via Discord. So feel free to reach out to Danilo, Block.Science, to Michael Sargam, Block.Science, to Kevin Owoki, Gitcoin Grants, Gitcoin, Jess from TE Commons, and Jeff. So these are the main point of contact. I'll add Joe, of course, and they are available on the Discord channel, and myself, of course, as well. Here's our chat channel. So this is the channel where you already posted your introduction. And then we have an additional video channel for all workshops. For example, the hacking session tomorrow. This will take place not in Zoom, but on Discord video channel. Just check this link here. And then staking on participation, I'll get to that in a minute. You'll find instructions here and also the kickback link for staking. So we will use kickback for stake on participation. Then the repos. As Danilo mentioned, there are 2 repos already in place. Jupyter notebooks with cadCAD models and simulations. You can find it here. Feel free to check it out, to fork it and work with it yourself. Then there's a reading list, which we want to expand continuously. So I'll include the links from Joe as well. And feel free to also add your links. This is an open document. You can edit it. And then there's the schedule. I'll come to that in a minute. Additional documentation and session recordings. So this is all here in the one-stop shop document. And let's check out the schedule here. So in total, we will have 8 weeks until April 2nd, where we have our final presentations. And throughout these 8 weeks, on Tuesday, we'll have workshops where we come together, share our research, brainstorm on our research questions, give presentations. So this will be always on Tuesday. I think the majority in this group is Central European or US or Southern America, right? So we don't have Asia. So probably the best time is something similar to today. Any objections here? Would this be suitable for you? Evening Central European? Okay, looks good. Then I think we should stick to that time roughly, and I will add that timings to the spreadsheet. Then this week we will have tomorrow the hacking session, and on Friday an alternative kickoff, because some of the folks in the research group haven't been able to join today. Next week, research directions workshop again on Thursday, the hacking session, and the first academic session on Thursday as well, 3.5 hours after the hacking session. And upcoming weeks, roughly the same schedule, bi-weekly academic discussions and Tuesday and Thursday sessions with working on the models. All right. So this is the schedule, and let's go back to the slides. Yeah, best time for Tuesday sessions as discussed. Now, finally, how to stake on participation. So you all know there's a deposit of 100 XDAI to be staked on the research group for participation. And you have to stake before February 13, so before Saturday, okay? To participate as a co-researcher, to have access to all the sources from Block.Science and Gitcoin, and you will get your deposit returned based on successful participation. So basically it's free to participate, but in case you drop off or we see just, okay, we dedicated a lot of time in the kickoff and onboarding people and then they disappear, you won't get back your deposit. And successful participation is what I've mentioned just beforehand. And you will get back this deposit after April 2nd. So this will be the post-event payout. And in addition to that, receive a proof of participation NFT as the member of this research group. All right. There are instructions. First, perhaps please let me know, do you all have XDAI? Or do you need any support in how to get XDAI? Nobody? I do not have CDAI, that's not a problem. Oh, XDAI, you don't have, okay. I'll go briefly, let's check out the instructions. Stake on participation, how does that work? Okay, first here's a summary. Can you see the screen, the document, stake on participation? Yeah, okay. Basic, it works like that. As we already noted, what's important to know is kickback charges a 5% fee. So you will have to, or kickback actually charges 5% for your deposit. So I think it's €5 from $5 to 100. Okay, just to let you know. And to get back your deposit, you will have to withdraw within 7 days after we finalize, but you will get a notification. So no worries here. How do I stake? Before you start, you should make sure to have a wallet, for example, MetaMask, that you are connected to the XDAI network, not Ethereum mainnet, and that you have at least 100 XDAI available in your wallet. Okay, then you go to kickback events. I've added some screenshots here. This is our event. Our structure for the deposits is a little bit different, so you can ignore this section, but anything else is important. So here my wallet is not sufficiently charged with XDAI. And if you want to, we can also run through this process in a second. You connect your MetaMask wallet. You go to Kickback, and then first you need to connect MetaMask and Kickback. So you can see it here. You will be asked to connect MetaMask and Kickback. Here you can see that Kickback is now connected with this wallet. In this example, the wallet is called Gitcoin Grants. And then make sure you select the XDAI network. And this is also important, make sure to edit your profile on Kickback and add your email, because only then you will get all the email notifications, right? And then you just click RSVP with 100 XDAI in the event. You wait a moment, don't click. I clicked 10 times, so I launched 10 transactions. That's not our goal. So you wait for a moment, and then MetaMask pops up automatically and asks for your confirmation to then lock 100 XDAI in a smart contract. It's not transferred, actually, it's locked to the smart contract. You check the transaction in MetaMask like here, and you confirm it. And then after that, your transaction will show up in the MetaMask transaction record. You can also check back. And finally, you receive a confirmation email stating the amount you've deposited. And that's it. Your stake is registered. You can also review it on the Block.Scout interface. This is the email. And pretty similar, you withdraw. You go to, you'll receive an email, and within this 7-day cooling period, you are able to withdraw your deposit. You go to this interface, can then define if you want to make a donation to TE Academy, but it's your choice. You can withdraw 100%, you can withdraw 10%, up to you. And then your transaction needs to be confirmed on MetaMask again. So there's again this confirmation. You'll wait a moment until your transaction is confirmed, and then your withdrawal will be visible in your wallet again, and you'll receive an email. So this is the process, and I'm sure we have a lot of people who are able to help with this process, and I'm also happy to help. Now, you have asked how to get XDAI. So if you have DAI in any of your wallets, then you're already fine. Then there's only one step necessary to transfer, or in a way, to transform your DAI to XDAI. So basically, it's locked in a smart contract, and then your DAI are not available in your wallet anymore. Instead, you can use it in the XDAI network and for staking. So Andrew, do you have DAI or?
I do have some DAI, yes.
Okay, cool. Then here's the instruction for how to get XDAI, right? What is XDAI? Where can I get XDAI? It's really pretty simple. There's a bridge and an interface that just, oh, do I have it open? Perhaps. I don't have it open. Let's check it out. It's a pretty simple interface. You connect your wallet. You state how many DAI you want to transfer to XDAI, and then that's it. And you have to connect your wallet. And for this, it's ideally you have a MetaMask wallet. It's then pretty simple. This is the bridge. It looks like that. Connect your wallet. You would need to connect your wallet. Wait, let's check it out in a Chrome browser. Oh yeah, there we have it. I've connected my wallet here. So this is my MetaMask interface. Takes a while. All right, so here, this is my wallet address. And for transferring DAI to XDAI, you need to be on the Ethereum mainnet. Later, for staking, you need to be on the XDAI network. Just keep this in mind. And then I connected, oops, right? Important, check out the transaction fee. There might be phases where you have a lower transaction fee, but you have to launch a Ethereum mainnet transaction to have XDAI. In this sense, it's also maybe a good choice to, since you can get back your XDAI at any point in time, you can transfer perhaps a little bit more to XDAI to have it available over the next, I don't know, months and years. And then you just say, okay, go to that bridge, transfer 100 DAI to XDAI or even more, as mentioned, because of the fees at the moment. And then you say, okay, I confirm here at MetaMask, and then it takes a couple of minutes until this is confirmed that you have now less DAI on mainnet in your wallet, and on the XDAI chain, more XDAI. Okay.
Okay, thank you.
And once you have XDAI, then you can go to this is the Gitcoin. This was the test. This was, yeah, this is our Gitcoin Grants research group. I also have to submit XDAI to my wallet first, and then I can RSVP with 100 XDAI, I will again go to MetaMask and then switch to the XDAI network, have my XDAI available, right? And then confirm the transactions for kickback. Okay. So whenever you are running into troubles, feel free to reach out on the Discord channel. Otherwise, just take your time and do it until Saturday.
Thank you.
Cool. All right, let's check out. Have we had all our slides? Yeah, these are our channels. Discord channel. You can also visit our Twitter. I just Twitter account. I will tweet about this research group as well. And for this, it might be interesting to have your Twitter usernames and in the introduction so that I can tag you. So please add them. This would be cool to have. And then that's it for the kickoff. If there isn't any urgent question at the moment, that's it for this session. Again, we are in touch on the Discord. I will share the link to the one-stop shop, to the instructions, and to the session we will have on Tuesday. And until then, you are welcome to join us tomorrow, same time, for the hacking session with Danilo.
Perfect. Sorry, according to the meeting schedule, if we can start 1 hour earlier or some hours later, maybe it is better for me because I'm from Argentina and now, for example, it's 4 p.m. I don't know if that's possible.
So 1 hour earlier, or
yes,
yeah, we
maybe
probably also,
yes, or some hours later.
Okay, maybe drop some proposals in the Discord. Perhaps
Okay.
we need a voting, and well, then let's see. But thanks for letting us know. I hope we can find a good time for everyone.
Okay, perfect. Thanks.
All right. Good. All right, then. Thanks for staying with us, and I'm really looking forward to the next.
Angela,
week.
I have one question for
Yeah.
you. So I was actually going through the Notion page where you actually wrote the every possible. You're starting different programs in token engineering, and this is one of the thing, Gitcoin research thing, and there are a few other programs. So can you tell me a bit more about it?
You mean you have been visiting the website tokenengineering.org and the
Yeah, the academy
program?
thing. Yeah.
Okay, so in general, the Academy is community-driven education for token engineers. And we are trying to offer programs and sessions at any level. So we have ecosystem value flows. This is we had it as a 3 weeks part-time program with the first 2 cohorts and plan to do it again in March or April. This is for the very first step in designing token-driven ecosystems. So defining the stakeholders, the interactions, the value flows, and then come up with first ideas on mechanisms, and the end result of this course is then stock and flow diagrams. So not modeling at that stage. This is one course. Another course that we are currently preparing, had just a test run, is hacking cadCAD models for those who are eager to improve modeling skills in cadCAD, and also hack on it, being creative on using and improving, complexifying models. This is another one. And so you'll find there's a variety of courses. several levels. Most of the times we require applications because we have way more people that are interested than slots. Yeah, so that,
Yeah.
and
Yeah, just trying to get where,
Yeah.
for personally, where I would be best fit and where I would be able to do more and contribute more. So just asking, that's for the reason, yeah.
And when it comes to education, also, if you haven't, check out the cadCAD Bootcamp, an online course for cadCAD beginners. This will help you a lot in working and building your own cadCAD model.
Yeah, I've done the bootcamp thing.
Yeah, cool.
Yeah, yeah.
All right.
Yeah,
Anything
thank
else?
you.
Thank you, too. Okay, then. Thank you for being here today. See you tomorrow. And yeah, looking forward to what we'll be doing, discussing, and producing in this research group.
Okay, thank you. Thank you for your time, Angela.
Thanks, everyone.
Bye.
Bye.
Thanks, everyone. Bye-bye.